I did, but then it, how to say?
Then I just send again. Yeah.
Okay.
Yeah. Sometimes after you send, right, you need to make sure it is sent before you close your iPad. Otherwise, it's like, it's a transition. Yeah. I can understand. Yeah. Things happen like this. So this is also a lesson learned for us. Next time, if you go out and work and you're going to send somebody something, please make sure it's sent before you close your iPad. Yeah.
But then it said that this file is not supported.
The file is not supported.
Mm.
The file is not supported for sending. No, you send.
No, like when I open up, it says not supported.
Not supported means you cannot see your own stuff, right? Then where you save your file? So can you open the original file instead?
I did not save. Like every time I just send and then I delete.
Oh, I don't understand why you need to delete it. But okay, yeah. So okay, things happen like this. Okay, I don't want to see who's at fault or whatever, because that does not matter. But I just want to make sure that we learn something from this incident. So next time you don't face incident like this. Okay, good. Then let's come. So you cannot open a file from your side.
No.
Okay, usually I don't know. So this is the lesson learned. So whenever you do something, you just make a copy of it. Okay, so and especially when you do when you do things digitally, you have to back up. That's why we need a backup. Backup means you need to okay. By the way, you are supposed to do this one, right? 19A, right?
Yes.
Okay, good. So it's always good to have a backup. Okay, so if things go wrong, and then you can always come back to this original file. Okay. Another lesson learned for you is, because sometimes if you work on this and if your computer or your iPad crash, or suddenly it runs out of battery, and if you did not save, and then all your work just go up in smoke. All right, which you don't want, right? So it's important that you back it up. Okay. Okay, so I will just go through the more interesting one. The more interesting one. Any idea how well you have done for your test?
No, but I feel quite okay.
Good. So
I finished everything.
Pardon?
I finished everything.
Nice. Okay, so it's good that you are confident about it. So generally, when you feel confident about it, and the result won't be too bad. All right. Okay. Very good. So I think we had a very good preparation for it. Yeah. So that's the reason why you put in the efforts, and we put in the preparation. We have ample preparation before your test. That's the main reason why you are confident about the result. Okay, so let's wait for the result and take a look at it when it is released. All right. Okay, so I will be looking at question 11 first. Okay, over here it says using a scale of 2 cm to 1 unit and 1 cm to 2 unit. Okay, so can I understand where did you use the GeoGebra app, or you use something else to do question 11?
I use GeoGebra.
Okay, use GeoGebra. So if you use GeoGebra, right, I would say. I
haven't bought the graph paper.
Oh, okay. In fact, you already have another booklet of graph papers that is pretty good enough for general purpose. But of course, you should go ahead and use the actual one. And by the way, if you look at my screen, right, actually I have uploaded a A4 graph paper here, which you can print out for your usage. Can you see this? Can you see this?
Yes.
Yeah. Okay. Good. So before you get your hand on your booklet of graph papers, you can actually make use of this in the meantime. All right. So yes, let me just use this to do this question. All right. So the question is y equals to 20 minus 4t, and then it's 0 to 6. And okay, let me just park it one side by side. Put this left hand side. Then I should do a screenshot. If you use the GeoGebra app, it's very simple. You just have to key in y equals to 20 minus 4t, and then just crop out the section that you need. Then you can actually show the answer. It's pretty simple, right? If you use the GeoGebra app, which I highly recommend you to use. But during the exam, you might not have the luxury of access to this GeoGebra app. So you still have to learn how to use the graph paper to do it. Okay, let me just park this on the left hand side, and I will use the graph paper on the right hand side. Okay, good. So over here, okay, when you do graph question, right, everything should be done on a piece of graph paper. So I'm going to like demonstrate to you how you can actually answer this entire question on a piece of graph paper, which is on the right hand side, right? So let me go to command and then just supposed to use the pencil tool. Okay, good. And then it says I'm supposed to use y equals to 20 minus 4t. Y represent the temperature. So I write down the equation. Okay, and actually the format should be y equals to mx plus c. So I should write the minus 4t in front, 20 at the back. All right. So in this case, this is my m, this is my c. Even though they did not ask for it, okay, but just for my understanding, so I just write this down, right? And I'm supposed to I'm given a range, so the range is 0 to 6. Okay, so I'm not supposed to go out of the range, all right? So 0 is the lower bound, and 6 is the upper bound. Like you have the upper limit, upper bound, you have the lower limit, lower bound, right? So the next step is 2 cm to 1 unit on the t-axis. So the t-axis in this case is your horizontal axis, right? So for the t, I only need the positive values. And then for this, so before you can draw the graph, so you need to get a table out, all right? You need to get the table out. So the table, you can do it here. Oh, by the way, when you do the table, you're supposed to use a ruler. Okay, so the table should be a nice table with straight lines. So okay, I'm not supposed to use x because clearly it's t. Okay, so if you use x, you're wrong. So 0, 1, 2, 3, 4, 5, and 6. So when it's 0, you put it in, you get 20. When it's 1, you put it in, you get 16. And when it's 2, you put it in, you get 12. And when it's 3, you put it in, you get 8. 4, you get 4. 5, you get 0. 6, you get minus 4. Okay, so from this, you can start to see, so you need to be strategic about it. You need to plan your space, all right? like I said just now, T has positive values only. Okay, but for Y you have 20 to -4. So it's important that you need to be strategic about how you plan the space, right? So I can actually insert straight line here. So they say what y-axis is 1 cm to 2 units. So so this 1 cm to 2 units. So this is -2, this is -4. Yes, so I can actually do it here. So let me just bring it up a little bit. Okay, good. And then I just need positive value for the T. So I will just bring my this y-axis to the right hand, to the left hand side, or to the extreme left, right? I think I'm ready to draw it. Okay, let me just bring this to a side. Okay, good. So this is my Y, and then this is my T. Okay, then it says 2 cm to 1 unit. So if this is 0, 1 cm, this is 0.5. So 2 cm to 1 unit, this is 1. This is 2. This is 3. 2 cm to 1 unit. Does it make sense? Oh, sorry. By the way, this is 4 cm already. So you need to use a ruler, right? So I guess this is 1 cm. Okay, this is 1 cm. Okay, so 2 cm to 1 unit, so 1 is here. Okay, so this is 2, this is 3, this is 4, this is 5, this is 6. Good enough. You're not supposed to show more than 6. Okay, because you are given the range by the question, right? So don't give anything extra, okay? Because you are given the range for T, 0 to 6. So I show 0 to 6. Okay, use a ruler, measure. Next, 1 cm to 2 unit. So 1 cm is 2 units. So this is this one. Okay, so my 0, I probably want to move my 0 a bit to here. Okay, so 1 cm to 2 units. So this is -2, and this is -4. So so this is 4, 8, 12, 16, 20, 24. Yeah, the max is 20. So this is good enough. Okay, then with this, then you can plot the points. Okay, the first point is 0, 20, 0, 20. So let me use a different color, just differentiate. So 0, 20 is here. Then 116 is here. 2 and 12, 3 and 8, 4 and 4, 5 and 0, last but not least. Okay, so like I say, once you get all the points, then you start to try to link up all the points. So if you can link up all the points, so most likely you are correct. If you cannot link up all the points, so most likely you are wrong, or one of the points can be wrong. So yeah, it's quite easy to see whether you are right or wrong. Okay, so with this, I have drawn the. So after this, I need to label the line. So this is my y equals to -40 plus 40 plus 20. I'm sorry. Okay, so this is the graph you are supposed to show. So that is your part A done. Okay, next, state the gradient of the graph. Okay, so yes, so part B is gradient of the graph. So so you just write down B. So the gradient, use the small letter M. So the gradient is -4. Okay, then part C. When will the temperature of the meat be 0 degree? So 0 degree. Where's 0 degree? So this is in degree Celsius, right? This is T, right? So this is T hours. This is in degree. So at 0, 0 is here, right? So it's here. So 5 hours. So when will the temperature of the meat be 0? So 5 hours. So T equals to 5. Okay. Or when will the 5 hours? So it says what? At time T hours. So it's 5 hours. Okay. Next, what does the constant term 20 in the equation represent? Yeah, they ask for 20. So the constant term represent what? Y-intercept. Right? So what does the constant term 20 in the equation represent? So it's the Y-intercept. All right. Okay. So that's the that's how you complete the question 11 on a piece of graph paper. Are you clear? Are you clear? Give me a response so that I know.
Yes.
Yeah, okay, good. Thanks for the response after pushing you. Yeah. Okay, good. So not too hard. Not too hard. Okay. So the next question, which is more interesting, is the 7. Okay, 7. So this is another way. The question. Another way. Graph can be asked of you. Okay, let me just go to 7. So if you look at this shape, right? The A, B, C, D. Okay, this is a trapezium. Okay, this is a trapezium. Yeah. So they did not ask for it, but yeah. So trapezium. And please note down the spelling also. Okay. So if they ask you for the shape and you cannot, if you cannot spell it correctly, then you will be penalized. All right. So it's important that you know the spelling of trapezium. All right. So what is the relationship between AD and BC? AD is here. Then this is BC. I think it's pretty clear, right? Can you see the 2 arrows? So the relationship is parallel. All right. Then we talk about, I think in one of the previous lessons. So if AD is parallel to BC, so what happened to the gradient of AD and gradient of BC? Can you still remember the relationship between the gradient if they are parallel? I'm talking about part 2. So what's the relationship? Can you remember the relationship?
Y1 minus Y2.
No, that one is how you find the gradient. Okay, so basically you are talking about y1 minus y2 over x1 minus 2. This is how you find the gradient. Okay, so basically this is the formula to find the gradient. But now the question is the relationship between the gradient of AD and the gradient of BC. So that means what's the relationship? Are they parallel? Are they the same? Or are they 2 times or half? You know, the kind of relationship.
Parallel.
Pardon?
Parallel.
The lines are parallel. What about the gradient? You mean the gradient is parallel to the gradient? No, right? Gradient is a value, right? So the value of gradient 1, which is the AD, cannot be parallel to gradient 2, right? Because the value cannot be parallel to another value. So what do you think? Bigger, equal, smaller to M2. So what's the relationship?
The gradients are the same.
Correct. Okay. So in fact, let me launch GeoGebra so that you understand this point. And I just want to reinforce this point to you. So let me just create just 2 lines. So this is 2x. All right. So let me create another line with the same gradient. So another line with same gradient 2. So both have gradient 2. And then this is instead of just now is plus 0. So now it's plus 3. So can you see that Yeah, I hope you are looking at my GeoGebra graph right now. Okay, so can you see that over here? Hey, sorry, how come I go and delete something? No, I'm not. I don't want to delete. Okay, so can you see that I have two lines here? Okay, they are parallel to each other. Can you see they are parallel to each other? Okay, so the if you come back to this, can you see that the green is actually y equals to 2x? Okay, so this one is y equals to 2x. The equation for this line is y equals to 2x, and the blue line is y equals to 2x plus 3. Okay, so can you see that they both have the same gradient? Okay, so this means the gradient of the blue line, okay, is equal to the gradient of the green line. Okay, so when the gradient are the same, so I hope you can see the blue line is parallel to the green line in this case. All right, so similarly, if you make use of this concept, oh, by the way, the reverse is also true. If blue line is parallel to the green line, gradient of the blue line is equal to the gradient of green line. Okay, so the reverse is also true. Okay, so if the gradient of the blue line is equal to the gradient of the green line, so the blue line and the green line is parallel. All right, okay, so pretty simple. So we are actually making use of this conclusion. So this conclusion, if you can remember it, it will come very handy in the future. So handy means like easily available. You don't have to find the gradients. Okay, it's just like the formula for finding the area of the triangle. If you can remember the formula, then you don't need to go and waste a lot of time. All right. So yes, so the relationship between these two gradients is equal because they are parallel. So the gradient is equal. So just gradient AD is equal to gradient BC. By the way, the AD and the gradient BC, right, is a not small letter but small size. The gradient is bigger size. So the way you write is this. Okay. So in case you are wondering how do you write the gradient, so let's say this is your line AB, this is your line CD. So you want to represent gradient, right? So this is the letter gradient M. So you just write smaller AB. So this represent the gradient of AB, and this will represent the gradient of CD. Okay, that's how you write. Okay, that's how you represent. Okay, next. Then hence, what can you deduce about the gradient of the parallel lines? They are the same. Yeah, gradient of parallel lines, they are the same. Yeah, or they are equal. Very simple. They are equal. Okay, very simple. Yep. Okay, next. So instead of doing one, I think question 3 is more interesting. Question 3 is more interesting. So what here says what? The equation of a straight line is given as this y equals to mx plus k. So for which of the line below m is positive? So how do you know which one m is positive? M is positive means the gradient is positive. So which gradient is positive? So you have let's call this is the red color. Let's call this the green color. It might not look very green, so let me just insert a line here. Okay, green. Okay, then this is the black color line. So make a guess. Or yeah. So the which gradient is positive? The black one, the red one, or the green one? Yeah. Can you circle the one that you think the gradient is positive? So you only have 3 options. So this is gradient of the black line, this is the gradient of the red line, this is the gradient of the green line. So which one is positive? we are at this question. Can you circle the answer? Black line, red line, or green line? How come we are taking so long? You're supposed to take so long, by the way. That's one of the three. Wait, green. Okay. I think it's pretty easy. So once again, let me just get the question into yeah, thank you. Yep. Let me just briefly explain your answer. By the way, your answer is correct. So I just want to briefly explain it. Thank you for answering. Let me just get the question to PowerPoint so that I have more space to explain the question. Good. Okay, so let me just give you a snapshot, like a short summary. All right. So basically, you have gradient equals to 0. You have gradient bigger than 0. You have gradient smaller than 0. Okay. So these are the, I would say these are the, okay, you also have the extreme case. Gradient is very, very big. Very, very big. Later I will show you what is this extreme case. The gradient is very, very big. Okay, but let's talk about the first case. Gradient is equal to 0. What do you think? When gradient equals to 0, how does the line look like if your gradient is equal to 0? Can you make a guess? Or do you know how it looks like if the gradient is 0? How your line looks like? Straight line, yes. Horizontally straight line. Very good. Okay, so if the gradient is 0, it should be a horizontally straight line. Okay, this is not so straight. So let me just make it straight. Okay, good enough. So let me just make it bigger. Okay, so if the gradient is 0, this is going to be the line, how it looks like. So it's going to be a horizontally straight line. So if you have a gradient more than 0 means positive. Okay, more than 0 means positive. Smaller than 0 means gradient negative. Okay, so for positive, it's a slope up. Okay, it's a slope up. So for gradients more than 0, it's a slope down. Okay, it's a slope down. Let me just fine tune a bit. Okay, so over here we are talking about gradient. Over here we're talking about the shape of the line. Okay, so what do you think? What if your M is very, very big? Can you make a guess? If the M is very, very big, very, very big, I use this symbol. Do you know what's this symbol or not? It looks like a 4 flat 8 躺平的8. So your 8 is this, right? But now you just just make it lie flat. So what do you think of the how your line looks like if the gradient is infinity? By the way, this the meaning of this is infinity. Infinity means very, very big infinity. So what do you think? How the yes? So it's a vertically straight line. Hey, not bad, you know. We are not. I think we cover it, but we did not spend too much time on this. How come you know? Can I know? Where you learn this from? Your infinity program or guess? Oh, okay, good. Yeah. In fact, yes. So I think you make a very intelligent guess. Because why? It can only be one of these 4 scenarios. Right? Y equal. What do you mean by y equal? Y is equal to infinity x. Okay, yeah, kind of. Okay, okay, by the way, wrong. There is no y equals to infinity x. Basically, Okay, so I'm going to give you the equation. Okay, very good. But I like your this attempt, like y equals to infinity x plus c. So I like your attempt, even though it might not be correct, but I like your attempt. Okay, your attempt is applaudable, so worth some applause. All right. So let me just make this smaller, because I'm going to like give you a table so that you are going to have a table, and it's going to be very it's just like a snapshot, very easily digestible for you. So so over here, this column is the gradient column. Okay, so and this is the corresponding shape of the line. And I'm going to create one more column, which I call it the equation of the line. So equation. Okay, so for m equals to 0, right, the equation will be like y equals to, I just give you an example. So y equals to 1. Okay, then for this one, the gradient is bigger than 0, which means the gradient is positive. So I just give you an example. So it's x plus 1. So over here, your gradient is 1. Okay, and then for this gradient equals to negative. So it's a, okay, this is called a slope up. So this is called a slope, a slide down. Okay, so this is going to be negative. So let me just use C now, because it can be any value. Okay, let me just use C here. So what do you think of this? When the gradient is infinity, you said is y equals to infinity x plus c, right? In fact, there is no such thing, right? There is no such thing. But like I say, your attempt should be praised, right? Should be encouraged. Okay. I give you credit for it, but there is no such thing. In fact, it's just x equals to 1. Or it can be x equals to 2, or it can be x equals to 3. It really depends where you put your line. Okay, so this is the snapshot. Okay, given a gradient, and you should have the corresponding shape of the line, and you should also have the corresponding equation of the line. Okay, so if I go back to the question here, this one, so therefore the green line will give you a positive gradient. Okay, so your answer was correct. Okay, then like so this one, the gradient will be positive. Then this line, for this line, right, is a slide down, right? So this slide down is negative. This is also a slide down for the black one, so it's also negative. Okay, so just now we talked about when the gradient is infinity. So I just want to demo to you. This will be your gradient equals to infinity. Let me just insert a straight line here. So if you put the line here, the blue one, this will be your x equals to 1. Why? Because this is 1. Okay, so if you put your blue line, let me give you another blue line. If you put your blue line somewhere here, vertically straight at -2, so your this will be x equals to -2. Okay, so when you have an infinity gradient, this is the infinity gradient, this is also infinity gradient. Okay, okay, okay. Next, they say what? K is negative. K is negative. So K in this case is the what? The y-intercept, right? Then you just look at this line. This is the y-intercept 2. This is the y-intercept -3. This is the y-intercept 0. So which one give you a K is negative? Green line also. Okay, pretty simple. Okay, pretty simple. All right. So then the next step, part C, they say find the gradients of L1, L2, L3. So I will just go through one of them, and then you just use the same approach. You should be able to get the rest. All right. So let me just find the gradient for the green line. So I need to pick 2 points. So this is my 3, 0. Let me pick this point as well. This is 0 minus 3. So the gradient formula is y equal to y1 minus y2, x1 minus x2. By the way, the minus sign in between is fixed. Okay, it's fixed. It's always there. So okay, this is my x1 y1. This is my x2 y2. So I write it down so that I just need to like put in the value. So my y1 is 0. Just replace it with 0. Y2 is minus 3. So this is minus 3. So I just erase it. I put in minus 3. x1, 3. x2, 0. So you will see that this is 3. Use your calculator. This is also 3. So this is 1. So the gradient is equal to 1 for the green line, which is I think according to the labeling is line 2. Okay. Okay. So yeah. So I have figured out the gradient for this line 2. Can you see it's a positive? It's positive. So I'm not going to do for the other two because same approach. Same approach. Okay. Good. Are you getting it?
Yes.
Nice. All right. So very, very simple. And I assume that you are going to have another test next month, May, because the other students like Yusing and the other few students of mine, they are having they call it the WA2 in May. So do you have any tests in May? Do you have it?
Don't know.
You don't know. Okay, good. So it's okay. So I think for your Monday on last Tuesday, we had enough preparation for it. That's why you are feeling very confident about it. So the lesson learned here is the more preparation we have, then the better your result is going to be. Okay, compared to your test 1, because I think test 1 we did not have much preparation for it. Okay, that's why you kind of like you did not do very well. Okay, not to your expectation. So going forward, I want us to prepare for it. All right, because the more you prepare for it, I find that you should be able to score better, and then that is going to do wonders for your results, right? Okay, so let's get the test date. Let's get the test date fixed from your school. Then we can start preparing for it, and it's good to receive materials from you. All right. Okay. So yeah. So I think you do not have major problems for graph questions, do you? After going through like a few graph questions, do you have problem with graph questions?
No.
Very good. So I also don't think you have any problem with graph questions, because I think we have gone through a lot of graph questions. Okay, it's more than enough. Okay, to understand this topic. Okay, so the next one we will look at is the factorization, and then of course the opposite of factorization is opposite of factorization is. Can you make a guess? What's the opposite of factorization? Any idea? D factor. Oh, okay. Good try. Okay, good try, but wrong. Sorry. Okay, it's expansion. Yeah. Okay, it should be expansion. Huh? Okay. I'm not sure if there is such a word called defactorization. Okay, but I like your attempt. Okay, I like your attempt. Okay, so for question 6, evaluate the following expression using factorization. Okay, good. So you know this question, right? If you just do it normally, so what do I mean by you do it more normally? You do it normally, that means you use a calculator. Okay. Do you use a calculator or use factorization? So if you use a calculator, you just punch in minus 380. How come they give me this? Okay, doesn't look correct. But anyway, just 380 times 8.69. Okay, so divide by -1. Okay. Okay. Due to the limitation of this calculator, then let me just switch to this calculator. By the way, there is a calculator here also for the GeoGebra app. So let me just clear all. Don't save. Let me go to the calculator. How do I go to the calculator? By the way, I'm also exploring this. This is a graphing calculator. So let me see. Okay, this is a graphing calculator, so I cannot use GeoGebra. I need to use the other app. Let me go to the other app. By the way, GeoGebra, they have a few apps. Can you see here? Let me see. Calculator suite, CAS. Okay, this is the one. I'm going to launch. So it's bouncing here. Okay, good. So you can use this calculator. So this is another app by GeoGebra. It's called CAS Calculator. Okay, so click on this icon, then you get this calculator. All right. So like I said just now, you just need to key this into the calculator, and then they will give you the answer. So I'm supposed to key in bracket minus 380, and then times 8.69, and minus 8.69 times the 620, and then you press equal. Are they or equal sign? Okay, no, please check input. So what the heck? So let me just skip. It's my first time using this calculator, so it doesn't look good, it doesn't look right. So interesting. Never mind. So I'm still figuring out how to use this calculator. But anyway, I hope you understand my point. So if you want to find a value, you just key in all this into your calculator, like your normal calculator, and then you are supposed to get the answer. Okay. But this question, they want you to use the factorization method. So let's see how you can use the factorization method without using the calculator. Okay. So can you see that this is common? 8.69 is common. Okay, so you take out 8.69, then you have minus 380 left. So this is gone, so you have minus 620. So what do we have? 8.69 times minus this, minus 1000. Okay, this is a times. So this times this is minus 8690. So that's the answer. Okay. So without using a calculator, if you make use of the factorization method, you can solve a very complicated question. Okay, you can solve complicated questions easily. Okay, when they ask you to evaluate means find, calculate. So using factorization, you have to use factorization. If you use calculator, wrong. Okay, you need to use factorization. Okay, so please answer the question. Answer the question according to the instructions in the question. All right. Okay, so this is one very practical example. Okay, next. Cannot be, but never mind. So all right, so just demo another question. Let's take 6A. So you have 456 times 72, then plus 456 times 28, So they both have 4, 5, 6. So you can take out the common factor. Then gone, and then you are left with what? 72 plus 28. So 456 times 100 is 456 double zero. Pretty fast, right? So that's the technique you can use to solve two sets of multiplications quickly. Okay, that's how you can use the factorization method. Okay, next. Okay, so question 8 here. Over here, I think this kind of question looks, I would say looks new, but it's not hard at all. Okay, why I say so? Because they tell you this is the area, okay, and then this is the breadth. And then of course the question mark is the length, which you need to find, and then this is the rectangle. So all you need to do is area of a rectangle. What's the formula? So area of a rectangle, the formula is 2 times L plus B, right? Okay. So in this case, L is, you don't know, you need to find, but the B is A. Okay. So this one is equal to AB plus 10A. And then you just solve this, then you can find L. So what I do, I will just copy, get this question into a PowerPoint, so they have more space. Yeah, it's already transported here. So I just continue from here to L plus A equals to AB plus 10A. So what do you have here? Open the bracket, 2L, 2A, AB plus 10A. Right? Okay, good. And you need to find L, right? So bring the 2A over. So you have AB plus 10A minus 2A. Why minus 2A? Because this is a plus 2A. So when you bring the plus 2A over to the other side, you bring it over, so you need to change the sign. So the sign is from plus. So from plus, you change it to minus. Okay, because you bring it over. Okay, then continue to simplify it. AB plus 10A minus 2A, 8A. And then you need to divide by a 2. Okay. All right. So yeah. So your length is this. Okay. So yeah, that's it. All right. So similarly, you do the same thing for the B. Okay. So let me just get these two to the other slide. So like I say, this one is this question looks like completely new, but it shouldn't be too hard. You just have to follow the fundamental. What's the fundamental? So the fundamental is area of a rectangle is what? 2 times L plus B, right? Okay. Then your breadth is 5m in this case. So 2 times L plus 5m. Okay. So you just, and this one is going to be equal to this one. Okay. So what is this? So it's 5m in plus 15m. Okay. So once again, you just have to solve for L. But before you can solve for L, you need to open the bracket first. So you get 2L plus 10M equals to 5Mn plus 15M. So once again, plus 10M, you bring it over. So since it's plus here, you bring it over, change the sign to minus. Okay, so it's 2L left here, then plus 15M minus. Because you bring it over, so you change the sign. Okay, so simplify further. 5Mn, this one combined plus 5M. 2L. So divide by 2. Okay, very simple. Okay. So that's how you get 8A and 8B out. Okay. Very simple. Next. I will say question 9. I will let you do question 9. I did not circle question 9 for you to do, but let's practice the concept here. See if you can solve question 9. Yeah, I'll pass question 9 to you, and yeah, you can actually do it. Please check your iPad if your iPad is running out of battery. If it is running out of battery, please start charging it. If it's not, then just write it somewhere here. Write your answer on the empty space. Okay. I will pass question 9 to you. Let me go and grab a drink. So please do it here. Okay. Yeah, you're still not doing it. You don't know how to do or what? One line. Don't know how to do or attempting? Okay, good. 16 AX pieces of trying. Good, nice. Okay. The pieces of square tile of unit length. Okay. Where AS state two possible dimensions that can be formed by using all the tile. By the way, unit length means 1 cm or 1. Okay. So square tiles of unit length means this one 1 cm, 1 cm. Okay. So this question is more English than mathematics. You can continue. I just want to assist you a little bit. Unit means 1. Next time when you see unit means 1. Generally, it means 1. What is? Dimension? Oh, okay. The word dimension. Okay, so we talk about. I think you always hear the word 2D, 3D. okay, or 4D these days, or more ND, more than 4D. So 2D means 2-dimension. So 3D means 3-dimension. 4D means 4-dimension. And then of course more than that is multiple dimension. So dimension means, let's say I give you this. Okay, this is a 2D. This is a 2D. Then this is a 3D. So these days they talk about 4D. I also don't know what is 4D. Okay, because this is already a solid. Okay, this is already a solid. This is already 3D. I don't know what's more than 3D already. I also don't know. Or maybe they just, it's a gimmick. You know what's a gimmick? You know what's a gimmick? Gimmick means they try to like they like to sound very profound, like they like to sound very intelligent, but it does not make it doesn't make sense. So it's a gimmick, right? Not real. Okay, they just like to talk very intelligently, but no substance. No substance. Okay, so that's the meaning of dimension. So in fact, yeah. So what two possible dimension, meaning you guess the question mark. What are the two possible value for this one and this one? Yeah, that's what the question wants you to answer. Okay. Or maybe next time if you know what is 4D, you let me know. I don't know what's 4D. Oh, 4D I know. In Singapore, I know what's 4D. You know what's 4D? 4D is the lottery lah. Lottery. You go and circle the numbers. Okay, that's 4D. Oh, the lottery in Singapore is called 4D. Oh, but I'm not talking about the lottery here. I'm talking about dimension. Yep. Okay. So can you make a guess the two possible values for the question mark? Two D and 2D and 3D. Okay. What is 1D? One dimension. One dimension, one line. Okay, so if this is 2D, this is 3D, then 1D should be one line. One line is 1D. One dimension. But actually, you are asking me English more than mathematics now. Yeah. One line, it can be a straight line, it can be like this, it can be like this. So there's 1D, one dimension. Okay. That's okay. So let me just give you an idea what this question is actually asking you. Can you help me erase the screen? Erase your handwriting first. So this is an open question. Open question means there is no fixed answer. Okay, there are, as long as you can explain your answers and it makes sense, and then your answers can be accepted. Okay, so that's called open question. So what concept we are talking about here? We're talking about factorization, right? Factorization. So since we are talking about factorization here, then you just do factorization first. So I think you see the 4a. Then once you take out 4a, you have 5x here. And then you have, oh no, 4x, I'm sorry. And then you have 5y. All right. Where a, x, y are positive integer? Yes. Then once you have figured this out, right? So this is the pieces of square tiles. So pieces of square tile, what it means is, let's say we have 20 pieces. Let's give you an example. 20 pieces of this 1 cm, 1 cm. So how do you get this? Let's say you have 20 pieces of 1 cm to 1 cm square tile. So I think there are a few ways you can arrange them. One of them is you can have a 10 pieces here, and then you can have 2 pieces here, right? So that is how you get. That's how you get 20 pieces in total, right? So similarly, if you have these many pieces of square tiles, so your length can be 4a. Okay, it really depends on whether your 4a is longer than the other one. But so let's assume that 4a is longer than the breadth. So this one will be your 4x plus 5. Does it make sense to you now? So this one times this one. Okay, so because I give myself an example, 20 pieces of square tile, how do I arrange them? I arrange them 10p here and 2p here, right? And when you times these two together, you get 20 pieces. So this is one possible answer. The other one, of course, you get what? 5 and 4, right? Right? Because 5 times 4 will also give you 20. Okay? So therefore, I need to ask myself, what times what can give me this? And then when I do factorization, I realize 4a times this will give me the back this. So now your job is done. So now your job is done. So they say what? State 2 possible dimension of the rectangle that can be formed by using all the tiles. So what's for? I mean, then you just need to decide what's your A, what's your X, what's your Y. You can choose. Okay, they say what? A, X, Y are positive integer. Then choose the simplest. All right, you can choose A equals to 1, X to. I mean, you can choose. I think for A, X, Y, right? They should be different integers. So you just choose different integers for A, X, Y. So if you choose A to be 1, so it's times, then X to be 2, Y to be 3. This is one possible answers. All right. So if you follow this, it should be 4, and then you follow this is 8 plus 8 plus 15. That's 23. Okay, so this is one of the possible dimensions. So the dimension is 4 times 23. That's how you represent the dimension. Okay. Okay, that's how you represent the dimension. Okay. But so if let's say if they give you this, so since you are asking what is the dimension, right? So this is called 3D, right? Okay. So this is a 3D object. This is a 3D object. Okay. So if they ask you what's the dimension of the cube or cuboid, all right? So let's say if I give you this is 2 cm, 2 cm, this is 4 cm. So the dimension of the cuboid on the left hand side is this 2 times 2 times 4. Okay, so that's how you represent the dimension. Okay, all right, yeah. So okay, so that's how you can approach such questions. All right. Okay, so before we continue our second half, we take a brief break and then we come back in 5 minutes. Okay. Yeah, good. Yeah, see you in 5 minutes. All right, welcome back. Okay, so what have you been learning in school, by the way, for the past 1 week? Just to get an update from you. Anything interesting in your school? Just finish what? Factorization. Oh, okay. All right. Okay, good. Okay. By the way, do you have any questions from your school on factorization or other topics? No. Okay, good. So good to hear you have no questions. So which means you are catching up. Oh, not catching up. You are there. Yeah. So you are doing well. You are up to speed. All right. So let's get back to our homework. Okay. Yeah. So this is an open question, question 9. Okay. So it's a very good question. Okay. So this open question 9, right? I think is kind of like the bonus question during your test or exams, okay, in the future. Okay, so let's move on. Okay, so I will just pick a few questions on factorization, and I will give you a summary after that. Correct? Okay, so let's look at the factorization for 2 terms first. So let's pick one of them. So let me just get this out. Let me just get this out. Let me transport it to here. Right. Okay. So let me just erase the handwriting first. Okay, good. Okay, so when it comes to factorization, like factorize, this is factorize. Okay, this is the factorization of 2 terms. This is factorization of 3 terms. And later on, I'm going to explain to you a factorization of 4 terms. Okay, so yeah, so I'm going to give you a summary later on, a snapshot. What are the techniques you need to master before you can factorize 2 terms, 3 terms, and 4 terms. Okay, so let's start off with the 2 terms first. So I will just pick two questions. So let's pick 2B. Okay, so okay, so you have 9P plus 36PQ. So what is common? Oh, by the way, how do you find the common between 9 and 36? Okay, some students they cannot see the common factor. That's why they pick 3. By the way, 3 is not okay. 3 is common, but it's not the one you need to factor out. Okay, so some students they just pick 3, and then they end up with okay. So 3 is common, and then of course P is also common. Okay, let me just take 3 for the common factor first. So 3P, and you end up with 3, and then you end up with 12Q. All right, and then you can see that this is not the final answer. So if you end up with this, you are wrong, right? Because this is not the final answer. Okay, so what is the final answer? All right, so to get the final answer, you must know the technique to find highest common factor. Okay, so that's the reason why we learn HCF at the beginning of this term or beginning of this year. Okay, so how do you get HCF out of 9 and 36? So can you see you have a 9 here, you have 36 here. So how do you get the HCF out of your 9 and 36? So you put a 3 first, and you get 3 here, get 12 here. And then you can continue to give it a 3, and you get a 1 here, and you get 4 here. And then yeah, that's it. Okay, that's it. So the highest common factor between 9 and 36, is actually 3 times 3, which is 9. So therefore the factor you should factor out of this 9p plus 36pq, right, is not 3p. Okay, it's supposed to be 9p. So once you take out 9p, you're left with 1, and then you're left with 4q. And this is the final answer. Okay, so in order to factor out, you need to know the concept of HCF. Okay, so you need to know the concept of HCF. Okay, so let me just demo one more question, which is 2f. So 2f is minus 28 CW, then minus 8 WU. Okay, so the highest common factor between minus 28 and minus 8 is minus 4. Okay, so once you take out minus 4, and then you have the W common as well. So once you have taken out minus 4W for the first term, this is what I call the first term. This is what I call the second term. So once you factor out the minus 4W, your first term is 7C. And then your second term is plus 2U. So this is the final answer. Okay, so this is the final answer. So it's important that you know the concept of HCF. Okay, if not, you will not get the final answer. And if you cannot get the final answer, you are wrong. Okay, you are wrong. Okay, so that's why I never pick any question from 2 terms, because it's too easy. Okay, so I have picked 2 questions from 3 terms. So let's do the 3B. So for 12, 8, 20, so what is the highest common factor? 4. So you take out 4, 3A left. You take out 4 from this is 2B. Take out 4, 5C. Is this the final answer? Yes. Okay. So for D, so what's common? Minus 3C. So if you take minus 3C out, you get 2A left. Minus 3C plus 7X. Minus 3C plus 1. Okay, that's the final answer. Okay, so before I continue, I think I have shared with you, you can actually check your answer before you submit your homework or submit your solutions, right? How? Let me just take this example. So you expand it out again. Factorization is the opposite of expansion. So if I expand it out, I get minus 6AC, I get minus 21CX, I get minus 3C. So can I get back the original? Compare. Okay, I can. So if I can get back the original, that means my answer is correct. That means my factorization is correct. Okay, so you can do this, and you can check your answer before submitting your work. Okay. Okay. So in fact, for 2 terms factorization, 3 terms factorization, use the same approach. Use the same approach. Okay. So now, the harder one will be the 4 terms. The harder one will be the factorization of 4 terms. So let me just emphasize once again, how do you do 4 terms? Okay. So let me just get this question out. So please remember how to do 4 terms. 2 and 3 terms, they are very much similar. Okay. So before I actually do this question 5A, actually 5A, right? They have already done one more step for you, which makes your life easier. Okay, so let me expand 5a and back to the original. Well, they make life easy for you. So let me just get it back to the original. So it's 3ax, 3ay minus 4bx minus 4by. Okay, so in fact, for 4 terms, this is the type of question you will get. Okay, 1, 2, 3, 4. So yeah, 4 terms. That's why I call this the 4 terms factorization. Okay, so when you have 4 terms, okay, you just do it separately. Okay, so you don't need to draw this, you don't need to draw the line in between. Okay, but it's a good practice at the start. Okay, if you are good enough, you have practiced enough, you don't have to draw this line, but it's always a good practice. Okay, so I will do the left hand side first. So this is the 2 terms, this is all 2 terms. So like I say, the previous slide here, we have done 2 terms, we have done 3 terms. So same concept. How do you do 2 terms? Take out common factor. What is common? 3a is common. So take out 3a, x plus y. Okay. So once you have done for the 2 terms here, then you move on to the right hand side, which is here. Okay. Then you start to do these 2 terms. So basically you split the 4 terms into 2 and 2. And then you do it separately. So now I'm doing the next 2 terms. So if you do the next 2 terms, I hope you can see you have the minus 4b in common. So if you have minus 4b in common, you take it out. So once you have minus 4b in common, you take out the minus 4b, you have x left. And then you have plus y next. Okay, so you can easily check whether your factorization is correct. You expand it out and see if you can get back the original. If you can get back, your factorization is correct. If you cannot get back, you redo it. Make sure that you can get back. So now you have done for the 2 terms, you have done for the 2 term. Now you just combine it back. Just erase the line in the middle. Then you start to see what? You start to see they also have something in common. Just take out this common term, x plus y. So with a bracket means they are together. You cannot split them. All right, you cannot split these 2. When you bracket it, that means they are together. Can't split. So once you have taken out this x plus y with a bracket, so you are left with 3a minus 4. So that's the answer. So that's how you do 4 terms. So the strategy is what? The strategy is 4 terms, you break it up to 2 terms and 2 terms. So do it separately at first, at the beginning, then combine here, continue to take out common factor further, and then you will end up with this. Okay, so I'm not going to demonstrate the rest because it requires the same approach. All right, nothing, no rocket science here. Okay, not complicated at all. Okay, so with this, I think we are pretty much done for this. We are pretty much done for this homework. Okay, we are pretty much done for this homework, and we still have a bit of time, so I will take 10 because I think question 10 is very interesting, and I probably want to talk about the. I think there is one more point I want to talk about for graph. I think the next chapter in your school is graph. Am I right? The next chapter you're going to learn is graph. Am I right? Do you have your textbook with you? Or do you have your syllabus with you? Do you have your syllabus with you or textbook with you? No. Okay, good. So if I'm not wrong, yeah, your next chapter is going to be graph. Why I say so? Because the next chapter is graph. Okay, so I assume your school is following the order of the chapters in your textbook. Okay, so that's why I'm guessing your school is going to talk about graph next. Okay, you think is learning graph. Yeah, so seems like I don't know, her school is like slightly ahead of you, but yeah, it does not matter. Okay, whether her school is ahead of you or your school is ahead of her school, anyway, the two of you are ahead of the rest. Okay, at least ahead of your class or your school curriculum, because I understand that some of your classmates they might be learning Sec 2 already. All right. Okay, so let's look at this question, and I think there is one more point I want to talk about. One more point I want to talk about for graph. So that should sum up our graph chapter, and then we'll move on to the next chapter. Okay, after today. So Nelson's monthly salary is 300 more than twice Joanne's monthly salary. So X and Y. So Joanne X, Nelson Y. So X generally is the horizontal axis. Okay, Y is generally the vertical axis. Okay, so this is the convention. Okay, this is the convention, or this is the tradition. Convention. The way we used to do things is called convention or tradition. Okay. Find Nelson's monthly salary if Joanne's monthly salary is 2,000. Pretty easy. So who? Nelson is always $300 more than twice Joanne, 2J. Okay. So Nelson is always 300 plus more than 2J. Okay. Then so if Joanne is 2,000, so Joanne is 2,000, so just plug in the numbers. 2K. By the way, 2,000 is 2K. So it's 300 plus 4K. So it's 4,300. Okay. So similarly, what about 3K? Then you just change the 2K to 3K. So this one will be 6K. So you have 6,300. Okay. Okay. So pretty easy. Next, express Y in terms of X. So N is Y. So I just replace my N with Y. Then I replace my J with X. That's how you get your this one. Okay, over here it says using a scale of 2 cm to 1,000 on both axes and draw the graph. Okay, pretty easy. So what I need to draw is I'm going to draw this Y equals to 2x plus 300. Why I want to do write in this format? Because I want to write it in Y equals to mx plus c format. Okay, so in this case, my 2 is my m, my c is my 300. Okay, just for my understanding. It's a good practice to just write down these two, even though the question might not ask for it. But I think most of the time the question asks for it. So let me just put this one side. So looks like I need to put this beneath the question, because I'm going to use the I need to use the question. Just put it beneath the question. Yeah. So let me just use the graph paper. So you see, it's very handy. Okay, it comes in handy when I need a graph paper. So I need to close this. Don't want to save. Don't want to save. Yes, good. So from today onwards, I don't want to use the GeoGebra app unless I need to get the answers quickly, because it's not needed. Since I have this graph paper already. Okay, let me launch this. Okay, it's not launching. So let me just click on it one more time. This A4 size paper is already in the folder. So you just have to search for it. It's already in this folder. Okay. That means the link you get access to is always there. Just have to search for the A4 size paper. The title for the PDF is A4 size paper. Yeah. Okay, good. So this is the paper. So now I want to draw this y equals to 2x plus 300. And the scale is what? 2 cm, 2 cm to 1000 on both. Oh, on both. Okay. And yeah. So let me just hold on. Let me just look at the question again. On okay, good. I need to insert the line first. Let me just make it smaller. Okay, good enough. Oh, I can actually use the arrow. Okay, nice. So I just start from here. And then all right, nice. X and Y. Okay, good. And this is my X. This is my Y. And 2 cm to 1000. So this is 0. 2 cm. So this is 1 cm. This is 2 cm. So this is 1000. So I just use 1K now. 1K is 1000. Just to make life easy for myself. So if this is 1K, this is 2. Okay, hold on. Just let me just 1K, 2K, 3K, 4K, 5K. Yeah, done. Same thing. For this one is also 1K, 2K, 3K, 4K, 5K, 6K. Okay. For the X value, there is a range 0 to 4K. So yeah, I have more than necessary. So for X, I will just stop at 4K. Okay, because the scale or the range is 0 to 4 for for X. Okay, so 0 to 4K for X. Okay, you're not supposed to show more than 4K for X. If you show more than 4K, wrong. And now with this, and create a table. Okay. By the way, I can create a table using a just realize that I can draw straight lines. Okay. So this is my X, this is my Y. You have your 0, you have your 1K, you have your 2K, 3K, and then finally 4K. So the formula is 2x plus 300. Okay, so Y equals to 2x plus 300. Okay, so when it's 0, 300. When it's 1K, 2300. It's 2K, 4300. 3K, 6300. 4K, 8300. Okay. Please use a calculator. Okay, please use a calculator. You're allowed to use a calculator. Then you don't have to use your mental. You don't need to use your mentality or mental calculation. Yeah. Oh, so looks like I need to give more because my Y actually go up to more than 8K. That's why with the table I know that my Y is actually not enough. Okay, so the range for Y is not sufficient to cover the range of Y. So I need to give it more. So now you have 0 and 300. So over here, then you really need to zoom in. Let me just zoom in. Let me just zoom in. 0, 300. So 1K is here. Okay, I can understand that my line is just slightly off. So I need to put it to the, yeah, slightly off. Okay. So now it's aligned already. Okay. So 1K is here. So this is 100, 200, 300. So this is the first point. Okay. Okay, looks like I need to fine tune it a little bit. I can use 140. Let me check. Okay, good. So up down a bit. Yes. So it's 1K. 1K, I'm going to have 2300. So it's here. 1, 2, 3 is here. Okay. 2K is 43. So this is 1, 2, 3. 3 is 63. So it's 1, 2, 3. If you can't see it properly, just use a ruler. 4K, 83. Okay, so 83 is here. Looks like you see my table here is blocking. So my table here is blocking it. So yeah. So it's important that you need to be strategic about the space given. Strategic means you need to like have a strategy. Okay, plan. So 8300 is here. 1, 2, 3 is here. Okay. Then with the points, then you just link it up. So link up all the points given. So I choose line. So start from here. No. So I should start from here, then link it up. If you link up all the points, that means you are right. If you cannot link up all the points, that means something is not right. So if something is not right, then you have to self-correct. Okay, have to self-correct. Okay, good. So you have this is equal to y equals to 2x plus 300. Okay, this is your y equals 2x plus 300. Okay. So next, using the graph to find Joanne's monthly salary, Joanne, if Nelson's monthly salary is 5,000, 5,000, where's 5,000? 5,000 is here. By the way, this is Nelson's. So you just zoom in. 5,000 is here. So draw a line across. Draw a line across. Okay. And then it cuts here at this point. Then you just come down from this point. So it's not very accurate, I guess, but I think it's accurate enough. Okay, let me just zoom in. Yes. Okay. So this point is I will say 2.1, 2.2, 2.3, 2.3. Yeah. Actually, it's here. So this is 2.3. Okay. That's for Joanne. Okay. That's for Joanne. Yeah, correct. So actually, if you use your graph, the answer is 2.3. The actual answer is what? If you use the formula here. So 5,000 is the y now in this case. So 300. Then 5,000 minus the 300 is 4700. 4700 divided by 2. That will give you the x, right? So x is equal to 1. Did I make a mistake somewhere? Did I make a mistake somewhere? So this is 1350. Then how come my answer is off by so much? Any idea why? Let me just double check. Y is Nelson. So Nelson now is 5,000. So 5,000 minus 300 is 47. It's 47, not 27. So 47, this is 2. So it's 2350. Okay. So like I say, it's very easy to make mistakes. All right. So it's human nature to make mistakes, but you have to, if you find things that don't make sense, then you have to go back to the question and be able to self-correct. Okay, so 2350, yes. So the actual answer is 2350. Using the graph is 2.3K with 2300. So what do you think? Do you think 2300 is good enough? Do you think 2300 is good enough compared to the 2350? Do you think it's good enough? No. I will say, actually, if you can, okay, by the way, if you can get the actual number, then you probably want to fine tune or calibrate here. So let me just zoom in a lot more. By the way, I think there is a limitation here. You know what's the limitation here? Can you look at the thickness? Can you look at the thickness of my line here? The thickness of the line here is pretty thick. So let me just move it away. I hope you can see that. It's actually in between. The point that it cut is here. This point it cut actually is in between the 3 and the 4 actually. Can you see? It's in between. Yeah. So in fact, if you make use of the equation here, you can play smart. Okay, you know that is 350. That is the most exact answer. So in a way, you can also play smart here. Okay, so instead of choosing 2300, okay, on my first attempt, so what I will do is I will not choose 2.3K. Okay, I will not choose the 2.3K. I will just tweak. I'll just tweak my answer because I know the most exact answer is 2350. So I just tweak my answer. Okay, tweak means fine tune. Okay, just adjust a little bit. So I will just adjust a little bit. I will try to put the line in between the 3 and the 4, so that my answer is exactly equal to the answer given. So I will tweak my answer, and then I will get x equals to 2350. Okay. Okay. So are you clear how you should do tweaking? Okay, to get your answer very close to your this exact answer. But I will say 2300 is good enough. So in fact, right, I think the allowable, so because we are using graph paper, so when you use graph paper, when you do it manually, you're not expected to get a very exact answer, because ultimately this one is drawing. Okay, so when it comes to drawing, this slight difference is acceptable. So in fact, when it comes to drawing, right, there is an acceptable range. So the acceptable range is 2300 to 2400. So as long as your answer falls between these two answers, or these two lower limit and the upper limit, your answer is correct. Your answer is considered correct. Okay, so generally when it comes to doing graphs, okay, generally the answer is in a range. Okay, so as long as your answer is it falls between this range, your answer is acceptable. Okay, Okay, but if you manage to find the exact answer, you can actually tweak it so that your teacher can't fault you. Okay, can't fault you. Can't fault you. Okay. All right. Okay, actually, there is one more concept for this I want to talk about before we can end the lesson today, which is this. It's about the Y-intercept. I think we have not talked much about that. We have talked about the Y-intercept a lot, but there's this concept we have not talked about. Let me just create. Okay, let me just create the graph. Let's say I have this. Okay, so okay, good. So let's say I have this point. This is let's say this is okay. This is 0, 1, 2, 3, 4. So this is 4. Then let me say this is let me say this is 1, 2, 3. Okay, so just an example. So this is 4, 3. And then let me give you this point as well. Let me give you this 2, 2, 2. Okay. So now I ask you to find what is the function of the line. Okay. So I think you have no problem finding the function of the line because the function of the line always follow this format. Okay. So you just need to find out your M and you need to find out your C. Okay. So the M, you just use a formula, y1 minus y2 over x1 minus x2. So like I say, the minus is always there. Okay. So you just have to, so this is my x1, this is my y1, this is my x2, y2. So you just plug in the numbers. So y1 is 3, y2 is 2, so it's 3 minus 2. x1, 4 minus 2. Okay, good. So 4 minus 2. So 1 on top, then 2 below. Okay, it's a minus, not times. So the gradient is half. So now comes to the y-intercept C. So in this case, what do you think of the y-intercept C? So you might be thinking, hey, this is 0, this is 1. Hey, this line is half of, I mean, it's in the middle of, is in the middle between 0 and 1. So should I take C equals to 0.5? Should I just assume that C is equal to 0.5? What do you think? What do you think? So is C equals to 0.5? My reason is, since it's in between, so I take it as 0.5. Why yes or why no? If no, then how can I find C? So since your answer is no, so how do you find C in this case? So since your answer is no, how do I find C? By the way, C is the y-intercept. English meaning is y-intercept. So y-intercept is, you read from, okay, this is y-axis, this is x-axis. You read from the y-intercept. So over here, you can't read accurately. Then how? Do you have any way to find C? So both answers are no. Okay, I cannot take 0.5 as the C. I also don't know how to find C. Probably that's your answer. So this is the concept that we have not talked about. Maybe we have talked about it, but I don't think we have talked about it a lot. So I just want to highlight this one more time. If I have not talked about it, so I want to highlight it one more time. How do you find C? Without reading from the graph. Okay, so all you need to do is this. Let me just get back to this. So since I have already found my M, the M is given by these 2 points. Okay, so I put my half into the y equals to mx plus c. So y equals to mx plus c. So I know my M is half, so I put it in first. Okay. So now, once you have this, in order to find C, right, what you need to do, get the X, get the Y. If you can put the X and the Y into this whole thing, you will get the question mark C. So you just need to choose one set of value. Okay. So in this case, I will choose 2 and 2. I will choose 2 and 2. Okay. You can choose 4 and 3. Okay. I choose 2 and 2. So I choose 2 and 2. So my Y is 2. My X is also 2. So with this, right, 2 is equal to half times 2 plus C. 2 is equal to 1 plus C. So in this case, C equals to 1. So in fact, in this case, C equals to 1. So the Y-intercept is actually 1. Okay. So in fact, my this one is a bit off. Very off. The scale on my Y is very off. Do you know why it's off? Because I never use a ruler. I never use a ruler at all. Okay. So in fact, the C is equal to 1. So I chose 2 and 2. So what if I don't choose 2 and 2? I choose 4 and 3. Am I getting 1 for the Y-intercept? Let's check. So let's check. So instead of choosing 2 and 2, I choose 4 and 3. I put it in. So instead of 2 and 2, my Y is 3. This is your Y, right? So X is 4. So 3 is equal to half times 4 plus C. So 3 is equal to 2 plus C. So C is equal to 1. Yes, so I will get C equals to 1 for regardless. Okay, regardless. So what this shows is to find your C accurately, okay, you just have to either choose this pair of X and Y, or you can also choose this pair of X and Y. Both should give you the value for C. Are you clear? How do you find the Y-intercept C without reading from the graph? Because sometimes the graph here can be, they might not give you the scale for the Y-axis, or like my Y-axis just now, the scale is very off. Okay, the scale just now was very, very, very off. Okay, so this is another way for you to find the Y-intercept C. So option 1, read from Y-axis, which we have talked about so many times. Then the second way to find the Y-intercept is calculate. Calculate by choosing one pair of X and Y. Okay, so I've demonstrated to you. I chose this at first, and I chose this on my second attempt, and both give you C equals to 1. All right. So to find Y-intercept, you can take the first option, or you can choose the second option. Both options should give you the same answers. Okay. In fact, I always prefer the second option because the second option is the most accurate. Okay. Sometimes if you read from the y-axis, sometimes it's a bit off. Okay. Because of the limitation in the graph paper. You just look at this. Okay. Just look at this. Okay. So sometimes this point can be like a bit off. Okay. Can be a bit off. So in order to get the most accurate one, you are advised to use option 2, calculate by sub in the x and y, okay, to the equation after you find the gradient. Okay, so with this and yeah, with this I think we can conclude the day, unless you have more questions for me. Do you have more questions for me?
No.
Okay, good. So if not, then I will see you next week. Then I will post the assignment. I think I already posted the assignment, right? Did I? Let me double check. Let me see 19B. Oh no, you finished 19A, right? So yeah, you finished 19A. So I will post the question by midweek. That means by Wednesday. So you get to see the latest questions on Wednesday. Okay. Okay. If you have no more question, then I can end the lesson here. So thank you once again. Yeah. Enjoy your day ahead. Bye bye.